This is a new section from your book, section 3.2 on logarithmic functions and their graphs. And I told you guys that you didn't need to write down the beginning part. I told you that you didn't need to write down this beginning part, but I do want to just talk about it quickly. So if I can have eyes and ears up here, please. Just an inverse reminder, first of all, if you have a function such as the one that I have drawn right here, it's okay, talk to me. Does f of x equals x squared minus 6x minus 27?
Whoa.
Does it have an inverse? So I graphed it quickly. I got this. Does it have an inverse?
No.
Do you remember what? You should know this. We talked a lot about it.
Ricardo.
Does this have an inverse?
It does indeed.
Okay, let me refresh your memories. It does not have an inverse.
I don't want to tell him.
And it does not have an inverse because it does not pass the horizontal line test. Remember that?
Yep.
If you drew horizontal lines and it only crossed the graph in one place, each time you drew a horizontal line, then it had an inverse. In this case, because when I draw the lines, it doesn't have, it touches the graph in more than one place, therefore it does not have an inverse. And the reason it doesn't have an inverse is because if I were to solve this, there are multiple x values that are going to get you the same y value. So for example, right here and right here, we have an x value here and we have an x value here that are going to get you exactly the same y value. So if you were to undo this equation and solve for x, you would always get, not always, but usually get two answers. And that means that you don't have an inverse. So the question here is, does f of x have an inverse?
No.
No. And you might even want to say it doesn't pass
HLT.
HLT.
Ooh.
HLT meaning horizontal line test. I said that because we talked about that a lot. Okay. All right, what about this? F of x is equal to 10 divided by x minus 2. Does that have an inverse? Well, does it pass the horizontal line test? If I were to draw these things, yes, it does have. It does always only touch the graph in exactly one place, so we say yes, it does. And then you would want to say it passes HLT. So it does have an inverse. Okay, I wrote this over here because when you have a function like this and you know that it has an inverse, I want to take you back to, I guess, chapter 1 for a second and solve it. What was the first thing that you had to do in order to figure out what the inverse was? What was the first thing you had to do? Yes, what does that mean?
Switch the y with that.
Yes, we had to replace
X.
the y with, so we put x is equal to 10 divided by y minus 2, solve for y. What is the first thing you need to do to solve for y, guys? Help me out here. What do you do?
Add 2.
Plus 2.
Add 2. So you add 2 to the right, you add 2 to the left, so you end up with x plus 2 is equal to 10 divided by y. We're trying to solve for y, and whatever the letter that you are trying to solve for is in the denominator, you have to switch it with the other side. So that means we're trying to find this, we switch it with the other side, so y is equal to 10 divided by x plus 2. So that would be the inverse. So this is kind of what we're doing now, except since we are using exponential functions, we're actually going to be finding the inverses of them by using what we call the logarithmic function. Okay, so this is where I told you guys that you needed to start writing. So what about f of x is equal to 4 to the x power? Well, first of all, if you were to graph f of x is equal to 4 to the x power, this is what the graph would look like. The inverse of this logarithmic function is called, the inverse of this is called the logarithmic function. So this is the exponential function. First of all, does it pass the horizontal line test? It does. Therefore, it has an inverse, and the inverse is called the logarithmic function. And that's what we're going to start working with today, is how do you undo an exponential? You undo an exponential by using logarithms. All right, definition. For any x value that's greater than 0, and for any a value that is greater than 0, also note that the a value can't be 1. This rule does not apply if the a value is 1. Then, okay, this is where I really need you guys focused here. Y is equal to log base a of x if and only if x is equal to a to the y power. So you guys need to be able to go from logarithmic form over here on the left to exponential form over here on the right. And we will practice this. In fact, I have some examples coming up here in just a second. And you also, if you have an exponential situation, in other words, the situation on the right, you need to switch it to logarithmic form, which is over here on the left. These two forms are equivalent forms. You just need to be able to go from one to the other. All right, examples. And I wrote this down at the top. You probably want to write this down right above where these examples are, because this is the notation that you need to be able to flop between. Examples. You just have to be able to evaluate these things. Evaluating. So in other words, the first example, log base 4 of x when the x value is 64. You need to figure out what is the value of the logarithm there. So what I'm really asking you guys to do is evaluate log base 4 of 64. So I am asking you guys to do this. Log base 4 of 64. This no longer is something that you can just type into your calculator. The calculator does everything in base 10. This does not have a base, this does not have base 10. What is it? Base what?
4.
Base 4. So we have to figure out, now by the way, this is logarithmic form. We need to change this so that it is in exponential form. So in other words, what we need to do is figure out what power are we putting 4 to that will get us 64. So 4 to what power is equal to 64? 4 to what power is 64? It's 4 to the third power. So the x value, or not the x value, the value of the log base 4 of 64 is going to be that x is equal to 3. What about this one? Log base 5 of x. Log base 5 of x when the x value is 15,625. So you are calculating log base 5 of 15,625. So in other words, I am trying to figure out what power do I put 5 to that will give me 15,625. What is it? 5 to what power gets me 15,625? You guys are going to have to play around with some numbers. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is...
5 to the 6th.
Yeah, 5 to the 6th power will get me 15,625. So what is the value of this expression, log base 5 of 15,625? Should be 6. That's our answer, 6. What about this one? Log base 4 of x when the x value is 1. What this really means is we are calculating the log base 4 of 1. Now think about that, you guys. we are trying to figure out what power do we put 4 to that will get me 1. 4 to what power is 1?
0.
Yes, anything to the 0 power is 1. And that's something you probably have to commit to memory. If it's not there yet, you're going to want to commit that to memory. Anything to the 0 power is 1. So, so this value is 0. Oh, this one, log base 10.
Put it in the calculator.
Now that's base 10. You can certainly put that into the calculator because it's base 10. The calculator does everything in base 10. If it's not in base 10, we're going to have some tricks about what to do when you don't have nice answers like 3, 6, or 0. But what we're doing here is taking log base 10 of 1 over 10,000. So in other words, 10 to what power will get me 1/10,000? What do you get? What do you get? And because it's base 10, you literally can type into your calculator log of 1 divided by 10,000. I think you get a negative number, am I right? Negative 3?
I got negative.
-4.
Negative 4, I think is what.
Wait,
Did you
how-
maybe not put in quite enough zeros?
You probably put in 1,000, not 10,000.
Yeah.
Oh, my bad.
Yeah.
Wait,
Come on now,
wait, how do you
Cindy.
put it in your calculator?
You type log, and then
Right
a
next to the
parenthesis,
seven.
a parenthesis shows up.
No.
No, right next to the 7.
Good. Oh, that's why I did accidentally press second.
Oh, you did second, okay, yep. You seconded, change it to exponential form, so. Alright, so you do log, base 10 is assumed, you type in 1 divided by 10,000, you get negative 4? We good now? Alright.
Yeah, we good.
I think when you type log, a parenthesis shows up.
Yeah.
Technically, you should close your parenthesis after, but the calculator knows what you mean if you don't, so. Alright, are we okay with this? Let's move on. If f of x is equal to log base 10 of x, then I want you guys to calculate each one of these things. This is not a big deal. The reason it's not a big deal is because these things are all in
10.
base 10. Enjoy them for a few moments because they will get harder. Not horribly hard, but they will get harder. So f of 10, what I'm asking you to do is figure out what is the log base 10 when the x value is replaced with 10. So this just means log base 10 of 10. So in other words, 10 to what power gets me 10? 1. Yeah. And since it's base 10, that is just a matter of plugging it into your calculator. You end up with 1. Number 2, f of 10,000. Well, what you're trying to do here is calculate log base 10 of 10,000. Log base 10 of 10,000. So in other words, 10 to what power gets you 10,000? 4. And if you didn't know, you could type in log 10,000. It will tell you 4. F of negative 5. Log base 10 of negative 5. What happens then? Log base 5. Excuse me, log base 10 of negative 5. What does it tell you?
Error.
It says error. In other words, if you put 10 to some power, will you ever get a negative number?
No.
You're never going to, if you put 10 to any power, you will always get a positive number. It might be a very, very, very small positive number, but it will always be positive. It will never be negative. So this, we just say, is undefined. It's undefined. Log, this is log base 10 of 1/3. So what's the log of 1/3? What do you get? Yeah, negative, yeah, and that's fine, negative 0.48. Let's do, can we do 3 numbers after the decimal? Negative 0.477. I think is what I got.
I thought you said we couldn't get negative.
You cannot calculate the log of a negative number, but that doesn't mean that you can't get a
Okay.
negative answer. Yep.
Got it.
All right. Are we okay with that? Properties of logarithms. Write those down. Some of them are kind of common sense, but nonetheless properties that you might want to refer back to when you're working on your assignment. Log base A of 1 is equal to 0. And I said because. Why is it that the log of base A, and A is some value bigger than 0 but not equal to 1. In other words, it's some positive value not equal to 1. Why is it that when you take the log base A of 1, you get 0? In other words, take that logarithm and change it to exponential form. How can you change this logarithm so that it is in exponential form? This is the base value A. This value right here is the power that we put it to, and this right here is what it equals. I like to think of it as kind of like a spiral. Log base A of 1 equals 0, because if you put A to the 0 power, you get 1. So in other words, any logarithm of 1 is equal to 0. So the log of 1 is 0. Might be something you want to commit to memory. Log of 1 is 0. What about this one? If these two numbers match, the base number and then what you're taking the log of, if those two numbers match, it's equal to 1. And the reason that is because if you take this A value and you put it to the first power, what is A to the first power?
A.
It's A. So we're just going to say, well, A to the 1. A to the 1 power is equal to A. Number 3. Log base A of A to the power of X is equal to X. I almost don't like this one because it's so common sense. You just take this A power, which means you take this base of A, you put it to the X power. What do you get? Well, you get whatever A to the X power is. So log base A of A to the X power equals X, because A to the power of X is equal to A to the power of X. So you might be wondering, why am I telling you this? Well, for some reason they have defined this as being a property that is important, so I just wanted to make sure that I got the information to you. This right here, A to the log base A of X is equal to X. This right now, what form is this in? Is it in exponential form or is it in logarithmic form? It's in exponential form, and it looks like logarithmic form because we have the word log in it. But the problem is logs always say log of something. This is not the log of something. This is A to the power with a log of it. So what we need to do is take this exponential and we need to change it so that it is in logarithmic form. So this is going to be the log. What is the base value here?
A.
A, log base A of that value, log base A of X, is equal to the power. Well, what's the power? Log base A of X. Another one of those things that I think is just common sense. One more property. If the log base A of X is equal to the log base A of Y, well, what does that mean about X and Y? They're equal to each other. They're both logs. They're both same base value. We have an x here, we have a y here. So log base a of x is equal to log base a of y. That just means that the x and y,
Are equal
the
to
x and
each
the
other.
y have the same value. Another very, very common sense situation. I have 4 examples. I really want to get through them before you guys leave. I don't think they're going to take us long. Look at this, you guys. Log base 5 of 17
I have a minute.
equals log base 5 of x. What does that mean about 17 and x?
They're equal to each other.
They're equal to each other. 17 is equal to same base values. They're both logarithms. That means the 17 and the x are equal to each other, just like we talked about in property number 4 above. Look at your properties above. If you have log base 6 of 6 equals x, that means 6 to the power of x is equal to 6. So what is x, you guys? 6 to what power is 6? It's 1. Look above at your properties that you just wrote above. Look at this one. 7. We're just simplifying this one. 7 to what power is equal to 7 to the x power?
To the x.
I put an x here. So 7 to the x power is equal to 7 to the x power. Just a second, okay? 12 to the log base 12 of 10 power. Look above. What did it say about that? You guys, isn't it like example, isn't it number 3 right above the property right above?
Four, I think.
It's part of number, I think it was above number 3. Or it must be above number 4. It's property
So
number
log
3.
It's under
It's
3.
equal to x.
I think it's equal to this number right here. In other words, if you, this right here is an exponential form. If you change it to logarithmic form, we have log base 12 of 10 is equal to log base 12 of 10. In other words, this
Same thing.
put to that power is going to be equal to that.
Yeah, that's what it looks like.
Yes.
Yeah.
Guys, or
Okay. All right.